Okay, I am hoping that this video will be a little bit quicker than the last few. So let's see. So we're going to talk about what happens when we change dimensions. Um, because if we're talking about similar figures, then that means the dimension has changed and they're basically still the same, just a little bit bigger. So, or smaller. So the way we're going to do this is if the scale factor between two similar polygons, so no matter what the polygon is, whether it be a circle or a triangle, it doesn't matter. The scale factor is always going to be A over B or new over old, okay? So the ratio of their perimeters is also going to be the same, okay? So it will still be new over old or A over B. So we're just comparing side A to side B. And the ratio of their areas is going to be A squared over B squared. So if we're talking about three-dimensional figures, so keep in mind three-dimensional figures, that's anything that is like a prism, a pyramid, a cone, a cylinder, a sphere, anything like that. If you compare two radius, so let's say radius 1 to radius 2, the ratio of their surface area is still squared, just the same as this. Area is always going to be squared, and the ratio of their volumes is going to be cubed. So what I'm going to do is show y'all this little trick that I use, and I call this SAV, okay? So the S column is the comparison of their sides, their perimeter, anything that's one-dimensional. So that would be A over B. Area is taking this ratio. Now remember, a ratio is, or the scale factor is the reduced form, okay? So let's say we have two rectangles. If this side is 3 and this side is 9, then if I did 3 over 9, it would reduce to 1/3. So their scale factor would be 1/3. Okay, so that would be your S column. Okay, A squared over B squared would be 1 squared over 3 squared, which would be 1/9. And then volume would be A cubed over B cubed, or go back to your AB. So 1 cubed over 3 cubed, which would be 127. So these three numbers right here are your scale factors for finding the areas, volumes, and perimeters of figures if you only know minimal information, okay? So here's that table I was telling you. So here's your S column, your A column, and your V column. So if a cone, and we don't care about the dimensions, we just know the scale factor, okay? So if the scale factor is 2/3, then this is 2 squared over 3 squared. So that would be 4/9. The volume would be 2 cubed over 3 cubed. So that would be, it's a 3, sorry, 8/27. Okay, so side, area, volume. Okay, now 4/6, you want to make sure that it reduces. Okay, so see how when they took the sides, they reduced to 2/3. So it's the same here. So this would be 4/9, and this would be 8/27. Now here, if you start in this column, you have to go backwards. You always have to go back to the one-dimensional shape. So if this is the squared column, then that means I need to take the square root. So the square root of 9 is 3, and the square root of 16 is 4. Now that I have this column, I can go forward to this column. So now I would do 3/4, and I'm sorry, my handwriting is awful today. So this would be A over B cubed, so that would be 3 cubed is 27, 4 cubed is 64. So remember, these are your ratios, okay? They're not the actual sides, they're the ratios. Now, if you start in the third column, make sure you reduce it first, okay? 9 over 16 didn't reduce, that's why I didn't mention it, because there's no number that will reduce these. Taking the square root of something is not reducing it, okay? That's changing the value. Reducing is keeping the value, but making it smaller. So 8 will go into itself once. 8 will go into 64 8 times. So the ratio is 1/8. So I have to go all the way back to this column. All right, so that means if I'm in the cubed column, to go all the way back, I have to take the cube root. So the cube root of 1 is still 1. The cube root of 8 is 2. Now you're here, you can go forward and square it because this is the squared column. So this would be 1/4. Okay, so now we're back here in this column, 49 and 64. They do not reduce, okay, because you can't reduce these two. But I'm in this column, so I need to go back this way. So I have to take the square root. The square root of 49 is 7. The square root of 64 is 8. Now that I know that column, I can go all the way forward to this column and cube it. So this would be 7/8 cubed. So 7 cubed, I don't have that one memorized, 7 cubed is 343. So remember, this is a ratio. And 8 cubed is 512. So this is your ratios. All right, so we got 125 over 216. It's in the cubed column. These two won't reduce. So you got to go all the way back to the beginning by taking the cube root. So the cube root of 125, so you would do, on your graphing calculator, if you do math 4, it gives you a cube option, so 125. So that's 5. And then math 4 again, and do 216, and you get 6. So now that I know this, all I do is square it to get to this column. So 25 over 36. This is how you find the ratios. You're going to have the ratios to set up your proportions. So get comfortable with doing this. I will do this on every single problem because it's just easier that way. So triangle A is similar to triangle B. I don't care what kind of triangle it is. It's just triangle A and B. If the scale factor of A to B, so we're talking SAV table, okay? If you do the SAV table, it saves so much time. It's 4 to 5. So that means 16 over 25 and 64 over 125. I just go ahead and get all three no matter what it's asking for. And then that way I can just pull from it as I need it. So what is the ratio of their perimeters? Well, the perimeters are one-dimensional, so that's also 4/5. And what is the ratio of their areas? So you go to the area column, that's going to be 16 over 25. Okay, and that's all you do on each one of these. So now I have two pyramids. Don't care about their sizes or their actual dimensions. It says the pyramid X is similar to pyramid Y. If the scale factor of X to Y is 3 to 7, then 3 squared is 9, 7 squared is 49. 3 cubed is 27, 7 cubed is 343. So I have my three columns. So what is the ratio of their surface areas? Go to the area column. 9 over 49. What is the ratio of their volumes? Go to the V column. 27 over 343. Okay? All right, and then the next one here, I'm going to go ahead and set up my SAV table. So the information they're giving me is the ratio of their surface area. So they're telling me the ratio is 16 over 49, and since they're talking about area, then I have to put it in the area column. I have to go backwards, so the square root of 16 is 4. The square root of 49 is 7. I have to go to the volume column, so 16 times 4, sorry about that, 64, 7 times 49 is 343. And then you just answer the questions. What is the scale factor between the similar cones? The flat scale factor is 4 over 7. The ratio of their volumes is 64 over 343. All right, so now this is where it comes into play. So two spheres have a scale factor of 1/3. Okay, so two spheres have a scale factor. So their scale factor is 1/3. So 1 squared is 1, 3 squared is 9, 1 cubed is 1, 3 cubed is 27. Like I said, I always just create the table. It says the smaller sphere has a surface area, so that means I'm going to be using this column. Okay, so find the surface area of the larger. So see, I don't know anything about these two spheres other than they're similar. Okay, and there's obviously we know their scale factor because they told us. So all you're going to do is set up a proportion. Since we're looking for the surface area, we have to use the area. So that's 1/9. Now, it says the smaller sphere has a surface area of 16. Since 1 is smaller than 9, 16 will go in the top with the smaller number, and we're looking for the larger area. So we cross multiply. 1 times x is x, and then 9 times 16. So 9 times 16 is 144. So that would be feet squared. So the larger sphere has an area or a surface area of 144. I didn't need to know anything else other than the surface area of 1 and then the scale factor. Here it says the cones below are similar. What is the volume of the larger cone? Well, since they have given me, let's see, let me highlight. They gave me the two heights, so therefore I can find the scale factor by comparing the two heights. So the first thing I'm going to do is find the scale factor. So I'm just going to do small over large, just to keep it simple, okay? So small over large, ooh, that is really chunky. So that would be 12/18. So that reduces, 6 will go into 12. Oh, I don't know what is going on here. All right. So let's see if we can get this. All right. So 6 will go into 12 2 times. 6 will go into 18 3 times. I have lost my, let me go down here. 2/3. Okay. So this is my scale factor. Okay. So let me go back here. So now I'm going to do my SAV table. And let me see what in the world is going on here. All right, so my SAV table, I keep losing my pointer and I don't know what's going on. So if my scale factor is, let's try this. If my scale factor is 2/3, then this is going to be 4/9, and this is going to be 8/27. So we're going to set up our table here. So it says that we're going to look for the volume, so that means we're going to have to use this column right here. So I'm going to use 8/27. So now the only thing is we need to find the volume of this, okay? You have a formula chart. We haven't really gotten to get into finding volume of cones, but the volume of a cone is 1/3 pi r squared h, okay? So 1/3 the area times the height. All right, so I'm just going to find the volume of this first one. You're not going to have to do these on the assignment. I am just introducing this to you. 1/3 pi r. R is 5. And the height we said was 12. So I'm just going to type that into the calculator, but I'm not going to use the pi button. I'm just going to leave it in terms of pi. Just makes it a little easier, okay? So we've got 5 squared times 12, and then we're going to divide by 3. So that's 100 pi. So the volume, this is really giving me a hard time today. So the volume is 100 pi. So I'm just going to leave it like that, okay? So if the volume, and I don't know what is going on. Okay, so if the volume, the smaller is 100 pi, then I need to find this one. So I'm just going to cross multiply. So that's going to be 8x, and then 27 times 100 would be 2700 pi. So I cross multiplied this way. So I'm going to divide both sides by 8. So 2,700 divided by 8 is 337.5 pi. And I'm just going to leave it like that because clearly my computer has a mind of its own today. I'm not real sure what's going on. So let's try that one more time. So that's 337.5 pi, and that's going to be feet cubed. I am so sorry. All right. So you're just going to be mostly doing this in the assignment where you're setting up the table and you're going to use the information that's given, okay? You'll have to find basic area, but you're not going to have to do volume in this section. All right, so two rectangular prisms are similar, okay? Their scale factor, they're similar and their ratio of their sides is 2/3. So setting up the SAV table, okay, I think my computer has done whatever it was doing. So this would be 4/9 because it's squared. Cubed would be 8/27. All right, so now it says the surface area of the larger is 1944. What is the surface area of the smaller? So that means I have to use the area column. So I'm going to do 4/9. So the larger is 1944. So since 9 is larger than 4, I'm going to put 1944 down here, and I'm going to put x here. Cross multiply 9 times x, and then 4 times 1944. 4 times 1944. So that's 7776. And then divide both sides by 9. And I get 864. So centimeters squared. So 864. Okay, that's how simple these are. You set up the table so you find out which proportion to use or which ratio to use, and then put that ratio in your proportion. Okay, so let's do SAV. To me, this is so much faster than any other way I have tried before. So the ratio is 3/4. So squared is 9/16. Cubed is 27/64. And yes, I do have a lot of these memorized just because I do them a lot. So it's okay if you don't have them memorized. All right, the smaller cube has a volume, so that means I'm going to be using this column. So that means 27/64. So the smaller volume is 729. Since 27 is smaller, then I'm going to put 729 here because I'm looking for the larger volume. So it's got to pair up with the larger side. So cross multiply 27x, cross multiply 64 times 729, 46656. And then divide both sides by 27. 1728. And this is meters cubed. Don't forget your units because they're important. Okay? All right. Now this one, it says pyramid X is similar to pyramid Y. The surface area, so they're telling me, hey, the surface area is 135 and this surface area is 240. So I'm going to find what the scale factor is. So if we did X over Y, so 135 compared to 240, I need to simplify this. So 135 divided by 240, and then you know in your graphing calculators you can math enter, and it'll reduce it to 9/16. So this is the area scale factor. Okay, this is your A column, so SAV. So that means 9/16 goes in the area column because this is the area ratio. Okay, so to go backwards, take the square root, go forward, cube it, 27/64. All right, so now I can set up my proportion. It says if the volume of the pyramid X is 189, so we did X over Y, so I'm using 9, okay, if the, sorry, we're not using 9, back up. Okay, so if the volume, find the volume, so we need, oh, good gravy. So we're going to be using the volume column because we are looking for volume. So 27 over 64. So if the volume of X is 189, because we did X over Y, find Y. Cross multiply, 27X. Now we got 189 times 64. So that's 12096. Divide both sides by 27. We get 448, and that is centimeters. And we are looking for volume, so that is cubed. And that's all you have to do on those. So first thing you do is take the information that's given, put it in the appropriate column, find the other two. Then do whatever they're asking you. Use the column for what they're asking you to find. If they're asking you to find perimeter, you use the 1. If they're asking you to find any kind of area, 2. And if they're asking you to find any kind of volume, 3. Okay? And that is it. So I hope this was enough information to get you through, and we will see you soon.